Okay, because we know we're going to use the diagonals to do this check, I'm going to write the diagonals here. We know from A to C is one of the diagonals, and I'm just going to rewrite them in order so we can see that it's a diagonal. And the other diagonal would be from B to D. And the first thing we're going to check is to see, is it a parallelogram? And we're going to check to see if it's a parallelogram by using the midpoint formula. Midpoint formula from A to C then would look like this. -3 plus 3, x1 plus x2 divided by 2, y1 plus y2, -2 plus 0 divided by 2. Well, this would be -3 plus 3 would be 0. 0 divided by 2 would be 0. -2 plus 0 would be a -2. Divided by 2 would be a -1. So this is the midpoint of AC. And I'm going to check now to see if the midpoint of BD is in fact the same. And I do the same thing. x1 plus x2, 1 plus a -1, divided by 2. y2 plus y1, 2 plus a -4, divided by 2. Well, 1 plus a -1 is 0. 0 divided by 2 is 0. 2 plus a -4 is a -2. Divided by 2 is a -1. So, yes, it is a parallelogram. Question? Here, that's a 1 plus a -1. 1 plus a -1. x1 plus x2. Okay? The order in which I check to see whether it's a rectangle or rhombus doesn't matter. I'm going to check rectangle first. And I'm going to check the rectangle by using the distance formula. For those that don't remember, it is x2 minus x1 squared plus y2 minus y1 squared, all underneath the square root symbol. So, we're going to find the length of AC by using the distance formula. We're going to find the length of BD by using the distance formula. And we're going to see, are the diagonals congruent? If they're congruent, the answer will be yes, it's a rectangle. If they're not congruent, it's not a rectangle. So, in AC, x2 minus x1, I'd have 3 minus a -3 squared plus y2 minus y1, 0 minus a -2 squared. Well, my minus and negatives are going to change to what? Positives. 3 plus 3 is 6, but 6 squared is 36. 0 plus 2 is 2. 2 squared is 4. And I would leave this as the square root of 40. The only way I would change that is if it came out to an integer. I would not change it otherwise. Because if I took the square root of 40 and it came out to a decimal, and the other one came out to the square root of 39, and I changed it to a decimal, the two might look like they're close enough that they would be equal. But is the square root of 40 the same as the square root of 39? No. So, I personally would leave it this way. This is easy to compare. And we're going to do the same thing now with BD. x2 minus x1. Negative 1 minus 1 squared. Plus y2 minus y1. Negative 4 minus 2 squared. Negative 1 minus 1 more would be a negative 2, but what's a negative 2 squared? 4. Negative 4 minus 2 more would be a negative 6, but what's a negative 6 squared? 36. And I can see that this came up to the square root of 40. So yes, it is a rectangle. I still have to check to see if it's a what? I'm going to check to see if it's a rhombus. The unique thing about a rhombus is that the diagonals have to be perpendicular to each other. So I'm going to use the slope formula, which says y2 minus y1 over x2 minus x1. And I'm going to find the slope of AC. I'm going to compare it to the slope of BD, and how would I be able to tell if they are perpendicular? They have to be opposite reciprocals of each other. So if the slope of one was 2, to be perpendicular, it would be a negative 1 over 2, the reciprocal. So the formula says y2 minus y1. y2, 0, minus y1, negative 2. Over x2, 3, minus x1, negative 3. Both of my minus and negatives are going to become positives. This would be 2 over 6, which would simplify to 1 over 3. What would be perpendicular to this?
Negative 3.
A negative 3. So if BD doesn't come up to a negative 3, then this is not a rhombus. y2 minus y1. Negative 4 minus 2 over x2 minus x1. Negative 1 minus 1. Negative 4 minus 2 is a negative 6. Negative 1 minus 1 more is a negative 2. But a negative divided by a negative makes a positive. Are these perpendicular? No. It is not a rhombus then. If it's not a rhombus, it's not a square. If this had come up to a negative 3, it would have been a rectangle, it would have been a square, which would have forced it also to, it would have been a rectangle and a rhombus, which would have forced it to also be a square. Everybody good? Mm-hmm.
What was the formula that you used for the parallelogram? What's that called?
It is the midpoint formula, and it looks like this. x1 plus x2 over 2, comma, y1 plus y2 over 2. Everybody good? I am going to pass out a worksheet to go along with this, but you have 3 problems